Hello students. So we are back with the last session of this physics marathon part, and in this last session we'll be focusing on some of the questions from your AIATS plus phase 2 mock test 9, and that was conducted on 16th of March 2025. So the questions are primarily from these topics. So we'll be covering in this session electric charges and fields, electrostatic potential and capacitance, units and measurements, motion in a plane, and mechanical properties of fluids. Hi Faraz, hello, how are you? Kumaran, hello, how are you? Hope you all are enjoying. So this is your last session for this discussion part. Myself Puneet Kathuria, your physics faculty at Aakash. So let's continue with the discussion. Now, which of the following pair does not have similar dimensions? The dimensional formula, you have almost 120 dimensional formulas across your syllabus of 11th and 12th class. And you know the importance of this chapter is quite high, because if you know the dimensional formula, if you know the basic formula, then you can solve most of the questions just by putting the values in the numerical formulas. So what is this question is? Similar dimensions. So we have to identify which pair does not have the similar dimensions. So very easy. Let's attempt this question. So we have pressure. So what is the dimensional formula for pressure? So pressure dimensional formula for the pressure is given by this ml minus 1 T minus 2. Then we have another that is called energy density. So this was for the pressure, which was, we got it from force per unit area as this one. Then energy density. Though you should memorize all these formulas well, but sometimes it's easy if you develop the formula. So it's energy per unit volume only. So this is energy per unit volume. So what is the dimensional formula for the energy? It's ml square T minus 2 per unit volume, so it's L cube. So what it becomes? ml minus 1 T minus 2. So look at the dimensional formula of pressure and energy density. Both have same dimensions. Got it? But we have to pick the pair which does not have the same dimensions. So this is not your option. So this is not your correct option. Then we have angular momentum and Planck's constant. So angular momentum is given by basic formula as mvr. What is this mass? M. What is velocity? Lt minus 1. And what this r is? R is length only. So it becomes ml square T minus 1. So this is dimensional formula for your angular momentum. Now we have Planck's constant. So do we have any relation that gives you the expression for the Planck's constant? If you can remember any of the formula which involves your Planck's constant in the formula. Any formula you remember. So easiest of all is E is equal to h times nu, that is energy. This is the energy of wave, energy of photon, whatever it is. So this h is Planck's constant. So what is this energy is? ml square T minus 2, and frequency is T minus 1. So dimensional formula for Planck's constant comes out to be ml square t minus 1. So when you look at the formula of this and your angular momentum, so both the physical quantities, they have the same dimensions. So again, because we have to pick which does not have the similar dimension, so this is again not your correct option. So let's move further. Torque and kinetic energy. So what is the dimension for torque? So torque is R cross F. So this is the dimensional formula for the torque. Then for the kinetic energy part, kinetic energy is half m v square. So this half is dimensionless, will not participate. M being mass, v is speed. So dimensional formula is so dimensional formula of torque is given by this and kinetic energy is given by this. So again, they both have same dimensions. So again, look at which pair does not have similar dimensions. So we have to pick a pair in which dimensions are different for that given pair. So power. What is power? So let's write down power over here. So power is basically rate of work done per unit time. So this is work done per unit time. So work done dimensionally is ml square t minus 2 per unit time. So dimensions of power become ml square t minus 3. So this is the dimensions for the power part. So we have the dimensions. Pressure, we already have the dimensions of the pressure. So look at the pressure and the power. Do they have same dimensions? No. So power and pressure, that is the given pair out of the 4 options which does not have same dimensions or similar dimensions. And this was the question, which pair does not have the similar dimensions. So this is your correct option for the given objective question. So I think with this analysis of all the dimensions of all the given physical quantities, we have reached the conclusion that the 4th option, power and pressure, these are the 2 different physical quantities and they don't have the same dimensional formula, rather they have altogether different dimensional formula. Any doubt from this part? Any doubt? Uncle. So uncle, any doubt? If you have any doubt, please confirm your doubt, ask your doubt. Fine. Now, before we move to the next question, I would like to highlight one more numerical situation, one more situation based on this. So, shall we attempt that? Fine. So, let's suppose, take one example. Where x is written as a plus bt plus ct square. So x is given to you as a plus bt plus ct square, where x is defined in meters and t is defined in seconds. Got it or not? So these are the standard SI unit, because x, when it is defined, is in meters. So it means x is basically representing the position, and t being time, that is given to you as seconds. Now question is, find units of A, B, C. So I have asked the units of A, B, C, where A is there, B is there, C is there, and ABC is a physical quantity. So we have to define the units. So I think we all have understood the situation, what is being asked from you. So let's understand how to find it out. So this question is based on homogeneous rule or homogeneous principle. So this is based on homogeneous rule or homogeneous principle, and that says two physical quantities can be added only if they have the same dimensions or same dimensional formula. And two physical quantities can be compared only when they have the same dimensions or the same dimensional formula. So based on that, A will have the same dimensions or units as that of X. So definitely A will be in meters, because X we have defined it or taken it as in meters. So your A will also have the same units as meters. Now let's move for the B part also. So X is equal to BT. So units for B would be meter per second. So based on the same homogeneous principle, we have the dimensions or the units of B also as meter per second. Going by the same fashion, if I write down X is equal to CT square, what are the units for this? That would be X by T square, so that would be meter per second square. So this is your units of C. Now we are supposed to find out A, B, C. So what is the unit for A? That is meter. Then what is for B? Meter per second. And what is for C? So C is meter per second square. So ABC becomes meter cube per seconds cube. Yes or no? So do we understand how we got this situational example we have just quoted to understand one of the again important formats of your NEET question? So Ankul is giving me right option, Harshita is also giving, but you people are not writing C as LT minus 2. Yes Ankul, you are right. A as length, so B as LT minus 1, that is perfectly fine. Good Ankul, keep it up. So I think we have understood this situational numerical just to make you more comfortable with the concept of homogeneous principle. So any doubt from this part? Any doubt? If you have any doubt, please confirm it right now. Okay, so shall we move? Now this is the second question. The equation of motion of a projectile is given to you. 12x y is equal to 12x minus 3 by 4x square. What is the range of projectile is? So first of all, this is your projectile. And if you look at the situation, so you project a particle with some speed u at an angle theta, and it definitely follows a path like this. And you know, this path is basically the trajectory. And for projectile, what is the equation of trajectory is? So first of all, equation involves your y and x variable. So equation of trajectory involves y and x, and we have y is equal to x tan theta minus half g x square by ux square, where we know your ux is your u cos theta. The same equation of trajectory with some readjustment of the formula trigonometrically can also be written as y is equal to x tan theta 1 minus x by r. So these are the two standard equations which are basically used to understand these kind of questions. So you can compare this equation, standard equation, with the given situational equation, and you can see and you can extract all the variables involved just by comparing it. So this is the one. But today I'll give you a very fine concept, a very small possible shortest way to attempt this kind of numerical. So are you interested to understand this numerical in the shortest possible way? Shortest possible, just one click. Okay, fine. So just pay attention. So body is landing at this position and this is your range. The formula for range in terms of variables u, theta and all, so that would be u square sine 2 theta by g. I'm writing this formula just for your understanding part, because we have time, so that is why I'm giving you all these formulas, just to enhance your knowledge about the very same topic. So otherwise not required for solving this kind of situational numerical. Now coming back to this point. So this is the ground. So if you consider this starting point, the point of projection as 0, 0. So where the first 0, because this is considered as origin, so this first 0 is x, second 0 is also x, second 0 is y. So the coordinates for this is x0, y0. Got it? So this is the origin from where you are actually projecting your particle. Now look at the coordinates of the point where the projectile is actually landing now. So when you look at the coordinates, so it has x coordinate and y coordinate, but because this is on this x-axis itself, so x coordinate is there and its y coordinate is 0. And if you look at the x coordinate, we have already labeled or understood this horizontal distance travelled by the particle as its range. So this is something very interesting, very easy to understand this kind of format. So this is, so range. What are the coordinates for that point? So coordinates are x is equal to range and y coordinate is definitely 0. So now we'll make use of this concept to solve this kind of situation. So y is equal to what? Y is equal to 12x minus 3 by 4 x square. So ultimately we have to find out the value of x at y equal to 0. So when you put y equal to 0, so this is how it looks like, and so 12x is basically 3 by 4 x square. 1x goes with this, so 12 into 4 by 3, and that is your x. So what it becomes? So it becomes 16, and this x is only r. So the range of this particular projectile whose equation of trajectory is known to us, equation is given to us, is 16 meters. Do we understand? So look at this concept. So what we have understood in this situational numerical is, so we got to know these two equations of trajectory for this projectile. We have added the range formula for your better understanding. Then we have understood it conceptually also what this point of landing means to us. So it has two coordinates. The x coordinate is known as range at value of y, that is value of y is 0. You got it? And using this concept, we put the value of y is equal to 0 in this situation, in this given equation, and we got the value of x, that is your range, as 16 meters. So I hope we got this situation. Any doubt from this part? Anything you would like to ask? Anything you would like to confirm? Sure? So shall we move? So we have few interesting students. Harshita is there. Then NS Harshini is there. Ankul definitely is there. Radhesham Tomar is there. And somebody more is there. So shall we move? Any doubt? Be open, be comfortable. And you know why I am giving you this in detail is because all these questions which are being asked in all your AIATS Plus phase 2 test, or maybe those questions were from AIATS phase 1 part also. This is phase 2. All these questions are very close to NEET actual format questions. So that is why by understanding all these concepts in detail, at least you will be in a position to solve varieties of numericals revolving around these situational numericals. So I think we should move on. Ankul has asked me a question, always applicable, sir? Yes, only when you have a ground to ground projectile, that is for a oblique projectile, when it is projected from a ground and it is landing again on the ground, the same horizontal surface. So keeping your origin at the point of projection, and then when you apply the same equation at the point of landing, then y would definitely be 0 and the value of x will give you the value of range. Now let's move to the next question. The radii of circular path of two particles of same mass are in ratio 4:9. So you have radius ratio as 4:9. What will be the ratio of their speeds if they are acted upon by equal centripetal force? So we have centripetal force. So this is a two-dimensional motion. We all understand whenever a particle moves two-dimensionally in a horizontal plane, and that is in, or maybe even in vertical plane, but that has to be a circular path. So if a particle of mass m moves with speed v in this circle, so it experiences centripetal force, and that is directed towards center of the circle. Or you can say this is the force required for the particle to move in the circular path. So whenever particle is there, so it means this centripetal force will play and will bring the particle, or will help the particle to move in the circular path. And this centripetal force is given to you as mv square by r only. So this is the formula for the centripetal force. Got it? Now question is, so we have two particles and the radius ratio is given to us. So they are acted upon by equal centripetal forces. So we have forces F1 and F2. So m V1 square by R1 is equal to m V2 square by R2. Why we are writing m for both? Because they have the same mass that is given to you. So that goes. Got it? So V1 by V2 is R1 by R2 whole under the root. I think we can easily extract this formula from this situation. So this m cancels out on both the sides, then V1 by V2 is R1 by R2 under the root. And this is given to you as what? 4:9 under the root, and that gives you primarily the answer as 2:3, 2:3. So this was your question, what will be the ratio? So we were supposed to find out only the ratio of their speeds. So the ratio comes out to be 2:3. Any doubt from this part? Tanmay, sir, I have a doubt in collision wherein elastic collision the momentum of each body is conserved after collision. This statement is false. How? Elastic collision. Tanmay, I'll come to this part. You can raise this. Let me complete this part. So elastic and inelastic collision, these are the two different types of collisions we have. So don't worry. Momentum of each body is conserved. So this is a wrong statement, because total initial momentum of the system is equal to total momentum of the system after collision. So whenever we say it follows law of conservation of momentum, so that is valid for the system, not for the individual bodies. So please mark it very well. It is for the system, not for the individual bodies. So total initial momentum will remain same as that of final initial momentum of the system. Now Rn, center of mass shift is not 0. What do you mean by center of mass? So we are going out of the way. So this is not an open forum for all these discussions out of the way. So if you have any doubt from these particular questions, then you can raise, no doubt about that. But if you, take me to different situations, so that will disturb the whole routine. So please. So shall I come to the next question? Shall we? Okay. Now next question is quite interesting, and this is from the liquid part, that is 8 identical drops of water are falling in air, each with terminal velocity of 0.15 meter per second, and if they combine to form a single bigger drop, then terminal velocity of bigger drop will be. Now, first I would like to give you a brief conceptual discussion of this part, when the body will acquire the terminal speed or terminal velocity. So let's suppose you have a spherical body and you just drop this. This is a spherical body, its size may be r. So initially when it starts falling in a viscous medium, it is falling purely because of its weight, gravitational pull. So this is the situation initially. Then as it starts falling down, its speed increases, and all these layers of the fluid, they also come into relative motion, and you have a viscous drag. So this viscous drag is basically 6 pi eta r v, and this is because of Stokes law. Got it? So this is the second force And when it comes into play, we have already discussed, body starts falling initially because of its weight. The layers in contact with the falling body will also tend to be in motion, but they will have relative motion. So as you move away from the ball, their velocity keeps on decreasing. So we have, as per Stokes' law, so we have an opposing force. So that is given by 6 pi eta r v. Then because this is in a medium, so we have a concept of upthrust also. So it means initially we just dropped it, so there was only one force. But as this ball, this spherical body starts its motion downward in the viscous medium, two other forces are acting simultaneously on it. One is upthrust and one is viscous drag. Now, this is very important. After attaining equilibrium, so once you attain equilibrium, so first of all, what do you mean by equilibrium? Equilibrium means net force is 0. It means net downward force mg is being balanced by these two net upward forces. Do we understand this? It's quite interesting. So it means now once the body has attained its equilibrium, then it continues to fall with the speed so acquired, and it is this speed or it is this velocity downward that is called the terminal speed. And when you have attained the terminal speed, net force on the body is 0. Net acceleration of the body is 0. It continues to move with the same speed acquired, same velocity acquired, and that is called terminal velocity. So this mass can be written as 4 by 3 pi r cube into density of body into g. Upthrust, volume of the body into density of liquid into g plus 6 pi eta r v t, and it is this speed that is called terminal speed. Now when you rearrange it, what this expression will look like. So your terminal velocity becomes this standardized expression. Now, coming back to the same question, 8 identical drops of water are falling in air, each with a terminal velocity of 0.5 meter per second. If they combine to form a bigger drop, and you know when they combine to form bigger drop, density of drop will remain same. I mean, like, it is falling through air, so this liquid or this density of your medium, if I precisely write it as medium, so that would also be fine. So that would still be air. G is acceleration due to gravity and eta is the coefficient of viscosity. So keeping all the factors same, can we write it down? Terminal speed is directly proportional to radius square, size square for this spherical body. So this is your shortcut. So this is the step what we are actually looking for to attempt this question in one shot, that is objective step. Now it says 8 identical drops. So volume of 8 identical drops combine to give you a bigger drop. So let's say when they combine, the size of the bigger drop would become capital R. So when you solve it, can you understand this step? Now, so once we are here, then we can compare it just by comparing this expression. So for the smaller drop, this is 0.15 meter per second, and this is size of the smaller drop. For the bigger drop, your velocity becomes v, and this is capital R square, where capital R is the size of the bigger drop. Now just use this expression. So capital R can be written as 2R, so its square becomes 4R square. This R square goes with this, and when you multiply this, 0.15 into 4 is equal to V, and when you multiply it, so this becomes what? 0.6 meter per second, precisely if I maintain the same digits. So this is 0.60 meter per second. So that would be your answer for this situation. So let's pick the answer first. So this is the fourth option. So any doubt from this part? Any doubt? So Vishal Kumar, okay, fine. Rahul Elawat, very fine. Harsh, very fine. So they all have given me the right answer. That is the best part of it. Good, keep it up, bacho. Harsh, very good. Rahul, Vishal, very good. Tanmay, very good. So you people are doing great. So any doubt from this part? Any doubt? If you have to confirm anything from this particular question, this particular section, this particular concept, you are open to ask. From this part only, from this section only. Fine? So just, but what you have to understand is, you have to be particular about this formula, that terminal speed is directly proportional to radius square. So I think we should move on. Now, next question is again from an interesting area, and this is again one of the important areas for your NEET part. It says a dipole of dipole moment P. Here we are talking about electric dipole. So we understand electric dipole is like a positive charge separated from an equivalent negative charge. They are separated by some separation R. So this arrangement is known as electric dipole. So this is pair of charges, but one charge has to be positive, one charge has to be negative. So they are equal in magnitude but opposite in polarity, separated by the separation R. So this arrangement is known as electric dipole. Then this R is known as electric dipole length or separation of these charges. Then we have another terminology, what you call it as electric dipole moment. This I write it as P, definitely with an arrow. And you know what this arrow suggests you? This arrow suggests you this electric dipole moment is a vector physical quantity. It is a vector physical quantity, and its magnitude is given to you as charge multiplied by the dipole length, that is R. So this is the magnitude. But what about the direction part? When you say it's a vector quantity, then where is the direction? So it's always directed from negative to positive charge. So this is how this is directed from negative to positive charge, and this is in coulombs and this is in meters. Now when you place the same dipole in uniform electric field, so you have a uniform electric field. Now place the dipole like this, and this is dipole length L, and this is at an angle theta. Do we understand? Now, the net force experienced by the dipole, if you look at this charge positive Q will experience force towards this side, so that would be Q times electric field, and this is Q times electric field. These two forces are equal and opposite, so the net force would definitely be 0. You got it? But because these two forces are acting along two different lines, so what they will do, they will try to turn this dipole, and this dipole will experience some torque, and torque is PE sin theta in terms of magnitude, or in terms of cross product, the same torque can also be written as P cross E also. Got it? Now P is there, so this is a standard, E is there, but how the dipole is inclined or placed in electric field, so that angle is given to us as 60. So this is sin 60 degree. And what is the value of sin 60, bacho? What is the value of sin 60? So that is root 3 by 2, and that becomes the expression for your torque. So any doubt from this part? Uncle has given me right option as the second option, then Harsh also has given me the right option, Harshita has also given me right option, Uncle has given me right option. Good, keep it up. I am really impressed. You people are doing it, and you people are doing it wonderfully well. So, any doubt from this part? Any doubt? So, shall we move? Fine. Let's move to the next question then. 3 capacitors, 2 microfarad, 3 microfarad and 6 microfarad are connected in series. So can you see all these 3 capacitors are connected in series. So when you have connected in series, so how you will find out C effective? Before we read out the question, the rest of the part, and let's check what is the C effective for all the 3 series combinations. So when you have the series combination, so it is 1 by C1, 1 by C2, 1 by C3, and this is 1 by 2 microfarad, 1 by 3 microfarad, 1 by 6 microfarad. Take the LCM as 6, so this is 3 plus 2 plus 1, that makes it as 1. So C effective. So all the 3 capacitors are placed in series, so their effective capacitance would be 1 microfarad only. Got it? Let's move further. So they are connected in series across a 10 volt supply. So look at this battery. So you have a potential difference V1, V2, V3. You got it or not? And then you have charge. Got it or not? So C effective is now known to us. Can you find out the total charge flowing through the circuit? Yes, Q is equal to what? CV. So what is the C is? C effective. So what is the value of C effective? 1 microfarad. So let's keep 1 microfarad only. And what is the value of V? V is 10 volts. So this is 10 volts. So that gives me the answer for the charge as 10 microcoulomb only. So this is the total charge flowing through the circuit. Now, question says, so this is what you have, what you are shown in the figure. We have to find out potential drop across 2 microfarad capacitor. So we have to find out V1. Again, using the same formula, Q is equal to CV. This we have to find it out. This is C1, that is 2. What is Q? Now, if you look at this, so because they all are in series, so the same charge will pass through all the, because they all are in series, so it is the same charge, that is 10 microcoulomb will flow through all the series capacitors. So this will remain 10 microcoulomb. What is the value of C1? C1 is 2 microfarad, and that gives me the value of V1. So this micro goes, so this gives me 5 volt as the answer for this. So 5 volt. If they ask you to find out V2, how you will get the V2? So you will use the same formula. So Q is equal to C2 V2. So this is what? 10. What is C2? C2 is 3. So that will help me to define V2, and similarly we can find out V3 also. Any doubt? Again, Vishal has given me the correct option, 5 volt. Good, Vishal, keep it up. I am really impressed. Any doubt from this part? Sure? So I think we should move on. A point charge 16 microcoulomb is divided into 2 charges such that when they are placed 10 centimeter in vacuum, experiences maximum coulombic force. What that maximum coulombic force is? So let's build up the concept. So we have a charge capital Q. Let's divide it into 2 charges. One is small q, the other is q minus q. They are separated by some distance r, so the force between them becomes k q1 q2 by r square. So this is the expression for the force between these 2 charges. Clear? Any doubt from this part? I am developing a very fine, very fundamental concept that would help you to attempt all these varieties of questions in just one click. Just pay attention. This charge capital Q is definitely a fixed charge. Can you see this force is a function of small q? So can you differentiate this force with respect to small q? And you know, for maximum force, this has to be 0. So for the maximum force between these 2 charges, this dF by dQ has to be 0. So this K and R being constant, so what this dF by dQ is like, so we can write it down as Q times this minus Q square, and we need to put it as 0. So capital Q here being a constant one will not participate in the derivative part, and dQ of small q is 1 minus dQ, d by dQ of q square will give you 2q. When you put it as 0, so that gives me this one. So small q. It means if you divide this charge into 2 equal values, you will have the maximum force. But there is a valid logical question. Only this step will decide the maximum force between the 2 charges, or we have to check something more before we conclude it, yes, the force would be maximum. So for that, second order derivative will also be required, and second order derivative for this expression gives you -2, which is less than 0. It means the force has to be maximum. It means to define the maximum force, we need to check the second order derivative also. If it gives you the negative value less than 0, that would define the force would be maximum. Got it? So what you have concluded is, if you divide this charge into two equal halves, that would define the maximum force. So now that charge is given to you as 16 microcoulomb. Got it? Does this depend on the separation? No, it does not depend on the separation. But when you are supposed to find out Coulomb force, then this separation does matter a lot. So how? Let's attempt this one. So force between two charges is given by K Q1 Q2 by R square. Now we are finding the numerical value of the force. 9 into 10 to the power 9, that is the value of K in SI system and when charges are placed in vacuum. Q1 is 8 microcoulomb, so 8 into 10 to the power -6 into other Q2 is also 8 into 10 to the power -6. This we have just proved. That means if you split the charge into two equal halves, you will have the maximum force by R square, and that R 10 centimeter. 10 centimeter means 10 to the power -1 meter. And if I make it, okay fine, that would also do 10 to the power -1 for the square part. Now the rest is, you have to just calculate this part. So this is -12, it goes with this, so that gives me -3. It goes with this, that gives me 10 to the power -1. So it's 8 into 8 into 9 into 10 to the power -1 is the numerical expression. So that means it's 72 times 8 when you multiply it with this. So this is, and with this, so that gives me 57.6. So we have defined the Coulombic force, so it has to be in newtons. So this is all about this question. Let's check the answer also. Yes, 57.6 is the correct option for this. 57.6. Good. So this is all from my side. Myself Puneet Kathuria, your physics faculty at Aakash. So thanks for attending this session. I think you people had a wonderful session. We had a very big physics marathon part. So you people enjoyed it, and we did discuss all these AIATS plus question papers all across your physics concepts. So any doubt, keep contacting us and we'll help you. And I wish you good luck for your NEET 2025 and for other exams also. So I wish you good luck. Thank you. Till then, take care. Bye.